Triceratops is a genus of ceratopsian dinosaur that lived during the Late Cretaceous period about 69 to 66 million years ago in what is now Western North America. Bearing a large bony frill, 3 horns on the skull, and a large 4-legged body, exhibiting convergent evolution with bovines and rhinoceroses, Triceratops is one of the most recognizable of all dinosaurs and is the best-known ceratopsian. It was one of the last known non-avian dinosaurs and lived until the Cretaceous Paleogene extinction event 66 million years ago. It was one of the largest, up to 9 meters or 30 feet long, and 5 to 9 tons in body mass. It shared the landscape with and was most likely preyed upon by Tyrannosaurus, though it is less certain the 2 adults would battle in the fanciful manner often depicted in museum displays and popular media. The functions of the frills and 3 distinctive facial horns on its head have inspired countless debates. Traditionally, these have been viewed as defensive weapons against predators, or primarily used in species identification, courtship, and dominance display, much like the antlers and horns of modern ungulates. Triceratops inhabited floodplains and wetlands near rivers and streams. They may have used similar areas for grazing and nesting as many other herbivorous species do today. Fossilized footprints suggest that Triceratops didn't move beyond their wetland habitats. They stayed in close proximity to water sources. This creature was believed to consume mainly low-lying foliage, such as ferns, cycads, and palms, vegetation that would have been abundant in such an environment. Fossils of the Triceratops have been discovered in locations like Montana, Wyoming, North and South Dakota, as well as parts of Alberta, Canada. This suggests that the Triceratops had a relatively wide geographic range in these regions. Like all Kosmoceratops, Triceratops had a large skull relative to its body size, among the largest of all land animals. The largest known skull is estimated to have been 2.5 meters or 8.2 feet in length when complete and could reach almost a third of the length of the entire animal. The front of the head was equipped with a large beak in front of its teeth. The core of the top beak was formed by a special rostral bone. Behind it, the premaxillae bones were located, embayed from behind by very large circular nostrils. In Kosmoceratops, the premaxillae met on their midline in a complex bone plate, the rear edge of which was reinforced by the narial strut. By the base of this strut, a triangular process jutted out into the nostril. Triceratops differs from most relatives in that this process was hollowed out on the other side. Behind the toothless premaxilla, the maxilla bore 36 to 40 tooth positions, in which 3 to 5 teeth per position were vertically stacked. The teeth were closely oppressed, forming a dental battery curving to the inside. The skull bore a single horn on the snout above the nostrils. In Triceratops, the nose horn is sometimes recognizable as a separate ossification, the epinasal. The skeleton of Triceratops is markedly robust. Both Triceratops species possessed a very sturdy build, with strong limbs, short hands with 3 hooves each, and short feet with 4 hooves each. The vertebral column consisted of 10 neck, 12 back, 10 sacral, and about 45 tail vertebrae. The front neck vertebrae were fused into a syncervical. Traditionally, this was assumed to have incorporated the first 3 vertebrae, thus implying that the frontmost atlas was very large and sported a neural spine. Although certainly quadrupedal, the posture of horned dinosaurs has long been the subject of some debate. Originally, it was believed that the front legs of the animal had to be sprawling at a considerable angle from the thorax in order to better bear the weight of the head. Triceratops and other ceratopsids maintained an upright stance during normal locomotion, with the elbow flexed to behind and slightly bowed out in an intermediate state between fully upright and fully sprawling, comparable to the modern rhinoceros. In Triceratops, the weight of the body was carried by only the first 3 fingers of the hand, while digits 4 and 5 were vestigial and lacked claws or hooves. Its sturdy legs and well-developed limb structure allowed for efficient movement, but they were short, which meant the dinosaur was not capable of taking long strides. Triceratops could trot or gallop, and may have been able to reach running speeds of up to 25 kilometers per hour or 15 miles per hour on a quick burst. In terms of social behavior, Triceratops may have exhibited both solitary and social behavior, depending on various factors such as age and reproductive cycles. Preserved skin from Triceratops is known. This skin consists of large scales, some of which exceed 100 millimeters or 3.9 inches across, which have conical projections rising from their center. A preserved piece of skin from the frill of a specimen is also known, which consists of small polygonal basement scales. Triceratops had a weird neck. One of the most distinctive features of Triceratops hides behind the large, imposing frill. It possesses a weird ball and socket neck joint. The ball and socket joint, located at the base of the skull, allowed the skull to rotate in any direction. This gave Triceratops the ability to move its head in a circular motion, which would have been useful for foraging for food. It likely would have also carried strong neck muscles, which would have made it possible for the animal to rear its head up for defense as well as foraging. All those horns and bony frills made the Triceratops' head particularly heavy. That skull was roughly 30% the length of a Triceratops' entire body. For comparison, we humans possess a pivotal joint in our necks, which, while allowing some degree of movement, is not as flexible as those on a Triceratops. Our ball and socket joints are instead found in our hip and shoulder joints. This is part of the reason why we can move our arms and legs in such a wide variety of ways. Analysis of the endocranial anatomy of Triceratops suggest its sense of smell was poor compared to that of other dinosaurs. Its ears were attuned to low-frequency sounds. Triceratops held its head about 45 degrees to the ground, an angle which would showcase the horns and frill most effectively, that simultaneously allowed the animal to take advantage of food through grazing. Triceratops were herbivorous, and because of their low-slung head, their primary food was probably low-growing vegetation, although they may have been able to knock down taller plants with their horns, beak, and sheer bulk. The jaws were tipped with a deep, narrow beak, believed to have been better at grasping and plucking than biting. Triceratops' teeth were arranged in groups called batteries, which contained 36 to 40 tooth columns in each side of each jaw, and 3 to 5 stacked teeth per column, depending on the size of the animal. This gives a range of 432 to 800 teeth, of which only a fraction were in use at any given time, as tooth replacement was continuous throughout the life of the animal. They functioned by shearing in a vertical to near vertical orientation. The great size and numerous teeth of Triceratops suggests that they ate large volumes of fibrous plant matter. Some researchers suggest it ate palms and cycads, and others suggest it ate ferns, which then grew in prairies. An American fossil collector named George Lyman Cannon is often credited as being the first to discover a Triceratops fossil, a pair of horns attached to a skull plate near Denver, Colorado in 1887. He sent the horns to Othniel Charles Marsh, a professor of vertebrate paleontology at Yale University. Marsh identified the partial remains as a prehistoric bison. A year later, John Bell Hatcher discovered a more complete skull in Wyoming, causing Marsh to change his mind and identify the species as Triceratops. Paleontologist Charles Mortram Sternberg discovered the first Triceratops specimen from Canada in 1921, which he found while working for the Geological Survey of Canada in southern Saskatchewan. Years later, in 1946, Sternberg also discovered the first Triceratops fossil from Alberta, found in the Edmonton Formation, now known as Horseshoe Canyon Formation. In 2014, a group of researchers looked at evolutionary changes in over 50 Triceratops skulls from the Hell Creek Formation in Montana. They correlated the placement of the fossils in the rock with structural changes in the skulls. The skulls of Triceratops horridus came exclusively from lower layers of rock, while the skulls of Triceratops process came from the upper layers. Skulls from the middle layers had characteristics of both species of Triceratops, suggesting that one species evolved into another over a period of 1 to 2 million years. Triceratops were long thought to have used their horns and frills in combat with large predators, such as Tyrannosaurus, the idea being discussed first by Charles Sternberg in 1917 and 70 years later by Robert Bakker. There is evidence that Tyrannosaurus did have aggressive head-on encounters with Triceratops, based on partially healed tyrannosaur tooth marks on a Triceratops brow horn and squamosal. The bitten horn is also broken, with new bone growth after the break. Which animal was the aggressor, however, is unknown. Paleontologist Peter Dodson estimates that, in a battle, the Triceratops had the upper hand and would successfully defend itself by inflicting fatal wounds to the Tyrannosaurus using its sharp horns. However, Tyrannosaurus is also known to have fed on Triceratops, as shown by a heavily tooth-scored Triceratops ilium and sacrum. Although specific details about Triceratops' reproductive behavior are limited, it is believed that Triceratops laid eggs to reproduce. After mating, female Triceratops probably laid eggs in nests on the ground, where they would have been incubated in favorable conditions until they hatched. Young Triceratops probably received parental care for the first few years of their life. Triceratops exhibited rapid growth rates during their early years. Scientists have divided their growth into 4 phases, namely babies, juveniles, subadults, and adults. Fossil evidence suggests each of these stages was characterized by significant change in their physical features. Some of these changes include a reduction in the epoccipital bones of their frills, development of postorbital horns, reorientation, and hollowing out of the horns. Due to the notable differences between Triceratops individuals at different phases of growth, scientists think several previously identified ceratopsian genera may represent specific Triceratops growth phases. Why did Triceratops have a frill? Theories. Perhaps one of the most distinctive features of the Triceratops, aside from its 3 pronounced horns, is the large bony frill that extends over its neck. Their frills were also theorized to have a number of purposes, like the horns. These purposes range from defense, species identification, cooling, and mating display. Triceratops frill was a form of display. A Triceratops skull is characterized by a large bony frill on top of the skull and 3 dramatic horns that extend from its head. However, despite its impressive size, the frill was not particularly thick or strong, and it was likely just a form of display. These display functions could have been used both as warnings to predators to attract mates and show how strong the animal was, and to warn other members of the herd of predators close by. Frills may have even been brightly colored to use as a visible signal to the herd, and to recognize members of the species and group from a distance to show direction of travel. It provided additional surface area for the attachment of jaw muscles. The frill was highly vascular, which means it had many channels allowing blood to flow to the jaw and around the head. So while it may have served a defensive function, probably used for display or interspecies competition, it may have also had a more basic and biological function. Frills were thought, although heavily disputed, to have been necessary for the attachment of jaw muscles. This theory has not been accepted by the majority of scientists, because in this case, the head would have to be much less mobile. It was a result of sexual selection. Researchers have long questioned the reason why a Triceratops frill evolved. Some believe it is an aesthetic trait, while others suggest it evolved as a means of attracting a mate. The Triceratops frill is thought to evolve from females to males through sexual selection. This process favors traits that the opposite sex will be attracted to, such as horns and feathers, and of course, the most noticeable of these, the frills. Triceratops frill protected it from fights between males. Although these horns may have been used as a signal or display of strength more than anything else, they were also there as a deterrent and at times a weapon. A large neck frill made of bone certainly would have afforded some protection against the horns of a competitor, at least in head-on confrontations. Triceratops frill helped to regulate body temperature. The frill may have been primarily used to attract mates, but it certainly had more uses than just a signpost for other Triceratops, or any other member of the ceratopsian family. The frill and horn cores of Triceratops were used as thermoregulatory structures, with the horn cores interpreted as being especially important in the stabilization of brain temperatures at extreme ambient temperatures, and the frill serving a more consistent role in body temperature regulation. Defense against predators. Finally, and although it may be the most popular theory on the use case for all horned dinosaur frills and horns, is that they were used as defense against predators. This theory is especially popular in movies with Triceratops fighting Tyrannosaurus rex, and in the Jurassic Park series of movies. However, as much as it is cool to think of these two massive dinosaurs facing off against each other, it would have been much rarer than most people think. Ancestors the size of big house cats. By the time ceratopsian dinosaurs reached North America, during the Late Cretaceous period, they had evolved to the size of cattle, but their distant progenitors were small, occasionally bipedal, and slightly comical-looking plant eaters that roamed Central and Eastern Asia. One of the earliest identified ceratopsians was the late Jurassic Achelousaurus, which weighed 30 pounds and had only the most rudimentary hint of a horn and frill. Other early members of the horned frilled dinosaur family may have been even smaller. Triceratops wasn't alone in its horned splendor. Dinosaurs like Triceratops were part of a group known as ceratopsids. Ceratopsids, or horned dinosaurs, are characterized by their elaborate frills, beak-like mouths, and often impressive horns. They thrive in the Late Cretaceous period, roaming the lands of what is now North America and Asia. Some, like the Styracosaurus, had spikes radiating from their frills. Others, like the pint-sized Protoceratops, that measured less than a meter high, were a more modest affair, lacking the grandiose horns but still retaining the family resemblance. All of these walked on four legs, had a bulky build, and had massive frills and horns. Ceratopsian dinosaurs were herding animals, and all lived in the Late Cretaceous. They were also all herbivorous. Kosmoceratops, which lived in North America during the Late Cretaceous period, about 76 to 75.9 million years ago, had as much as 15 horns on its head, which is why it has been aptly named ornate horned face. The dinosaur was discovered in Utah by paleontologist Mark Lowen and his team from the Utah Museum of Natural History between 2006 and 2007. Kosmoceratops was an elephant-sized quadrupedal dinosaur that weighed about 1.2 tons and was about 4.5 meters or 15 feet in length. It was heavily built, standing at around 1.8 to 2 meters or 6 to 6.5 feet tall at the shoulders, and had a relatively shortened tail. Kosmoceratops also had one horn coming out of each of its cheeks and one on the tip of its nose. The entire skull was about 6 feet or 2 meters long. The rest of the Kosmoceratops head includes a triangular beak with pointed tips. The beak was toothless, but the dinosaur had a long row of teeth numbering about 100 in its jaws. Kosmoceratops and other related dinosaurs may have been capable of short bursts of speed, especially when defending their territories or escaping from predators. Juveniles would have undergone a period of rapid growth, which was sustained until maturity. A 2019 study by paleontologist Carolyn Gale Levitt found a high number of bone cells, osteocytes, and a dense network of blood vessels in the long bones of Kosmoceratops. The presence of these features also suggests that Kosmoceratops and their relatives were warm-blooded and had elevated metabolism. Pachyrhinosaurus, meaning thick-nosed lizard, is an extinct genus of ceratopsian dinosaur that lived during the Late Cretaceous period, 75 to 69 MYA. It was a large herbivorous ornithischian and was closely related to the more famous Triceratops. First named in 1950, Pachyrhinosaurus was unlike any other ceratopsid. Instead of horns over its nose and eyes, Pachyrhinosaurus bore a lumpy mass of bone looking like an enormous tree stump. In the following decades, the strange lumpy nose, technically known as a nasal boss, confounded explanation. It was usually thought to be covered with a thick layer of keratin, the same material that makes up claws and beaks. Occasionally, fanciful interpretations emerged, including the nasal boss being used as a bird bath, or the nasal boss being the bony base of a gigantic cone-shaped horn. Size estimates for the largest Pachyrhinosaurus species, Pachyrhinosaurus canadensis, indicate lengths of 6 to 8 meters, or 19.7 to 26.2 feet, and a weight of 3 to 3.6 tons. It was a herding, social animal that usually traveled in large groups. The development of characteristics useful in sexual selection, including competition between males, such as pronounced nasal bosses, occurred at approximately 9 years of age. Achelousaurus is a genus of ceratopsid dinosaur that lived during the Late Cretaceous period of what is now North America, about 74.2 million years ago. The first fossils of Achelousaurus were collected in Montana in 1987 by a team led by Jack Horner, with more finds made in 1989. Achelousaurus supposedly was about 9 meters or 20 feet long, with a weight of about 3 tons, 3.3 short tons. As a ceratopsian, it walked on all fours, had a short tail, and a large head with a hooked beak. It had a bony neck frill at the rear of the skull, which sported a pair of long spikes, which curved towards the outside. Adult Achelousaurus had rough bosses, roundish protuberances above the eyes, and on the snout where other centrosaurians often had horns in the same positions. These bosses were covered by a thick layer of keratin, but their exact shape in life is uncertain. Some researchers hypothesize that the bosses were used in fights, with the animals butting each other's heads, as well as for display. Achelousaurus would have been a herbivore, and it appears to have had a high metabolic rate, though lower than that of modern mammals and birds.